Hi everyone, let's get going on our final example problem. So we'll be doing example 13 together in your nifty applications of similar figure packet. So turn to question 13 and we will get started. Okay, so again, if you notice, we have a triangle within a triangle, which means typically we have similar triangles. So if you remember how we solved with similar triangles, this will be very similar. So if you want to try this one on your own, I say go for it. Otherwise, follow along with Miss Long. Let's do it. So it says a vertical post casts a shadow of 4 meters long on the horizontal ground. An oak tree 18 meters high and 20 meters from the post casts a shadow at the same time of day. Okay, calculate the height of the post. Okay, so we have this tree I drew in this picture. You'll have to draw in your own picture. Okay, so I have a tree, and here's my post. So it says a vertical post casts a shadow of 4 meters long on the horizontal ground. Okay, so this is our horizontal ground, so this will be my shadow. So this is 4 meters. Again, this is the shadow. Okay, it says an oak tree that's 18 meters high. So the oak tree is 18 meters high. So this is 18 meters high. Okay, and 20 meters from the post. Okay, so it does not say that the oak tree shadow is 20 meters. It says that the distance from the oak tree to the post is 20 meters. Okay, so the distance from the oak tree to the post is 20 meters. That is not the shadow of the oak tree. The shadow of the oak tree is this whole thing right here. Okay? And then it says we want to find the height of the post. So I'm trying to figure out what the height of the post is. Okay, so again, if it helps you, if you'd like to draw your two separate triangles, you can. I'll go ahead and do that real quickly. So I'm going to draw my oak tree triangle. So this is my tree triangle. And I'll just ballpark it. Let's see. This is about 1, 2, 3. Alright, and then it's okay. So this is about the size of that triangle for the tree. Oh, good golly, Miss Long. Okay, and then we have the post triangle. So this will be the post. Okay, what's my post triangle? Okay. And then, okay. Sorry guys, I should have done this in advance, but that's okay. You can just do it with me. And I definitely drew that one too long, but oh well, it doesn't really matter. I didn't write draw on the scale, so it doesn't matter. Okay, so we have our tree triangle and our post triangle. Okay, and then once we set up our proportion, we can solve. Okay, so I know some things about the post and the tree. I'm going to start with the post because we kind of know things about the post more than we know things about the tree. So the post, the height of the post, I don't know. Okay, so that, the height, I didn't know. Okay, so I'm going to put X for our height. So this is our height. And it said the shadow of the post is 4 meters. So I know that the shadow is 4 meters. This is the shadow. Okay, now the height of the tree I know is 18 meters. So it's 18 meters for the height of the tree. Now, I currently don't know the shadow length. So the length of the shadow of the oak tree, if the sun's up here, so again, if you want to draw on your little sun, the sun's up here, and it's casting these shadows. So the shadow of the oak tree is this whole thing right here. Okay, this whole thing. Okay, so if I know that the distance from the oak tree to the post is 20 meters, and the post shadow is 4 meters, how would I find the length of the entire oak tree shadow? Because I have these two parts to it. I would add them together. So the oak tree shadow is going to be this whole thing. So from here to here. So this whole thing. So the way I'm going to find is by adding these two together. So 20 plus 4 is 24 meters. So the length from here to here, the whole entire shadow length is 20 plus 4, which is 24 meters. So the shadow of my oak tree is 24 meters. Shadow. Okay. Sorry, guys, I'm really bad at spelling, so there we go. Shadow. Sorry. It says shadow. Just believe me. Okay, so now that we have our two triangles set up, guess what, you guys? We can set up our proportions. So we're going to be comparing the heights and the shadows, which it doesn't matter which one comes first. I'm just going to make it easy and do the height over the shadow. Okay, so I'm going to do the height in the numerator. And then I'm going to do the shadow length in the denominator. So shadow. So this is the shadow. And I'm just going to start with the tree. Why not? So the height of the tree is 18 meters over the shadow length, which is 24 meters. And then the height of the post I don't know, so I'm going to call that X. And the shadow length of the post is 4 meters. And guess what, you guys? After that, we just cross multiply and then we'll be done. So let's finish this problem off. Okay, and again, if you can reduce down your fractions, that would be very helpful. Do you guys know a number that will divide into 18 and 24? Absolutely, you guys, it would be 6. So I can divide 6 into each of these. So 18 divided by 6 is 3. And then 24 divided by 6 is 4. So it'll be 3 over 4 equals X over 4. Which you can probably already tell what the answer is going to be, but you know, it doesn't hurt to check yourself. So I'm going to cross multiply and see if I still get the right answer that I think I'm going to get in my head. Let's see. Okay, so 4 times X will give me 4X, and that will equal, sorry guys, I didn't leave much space. So 4X will equal 3 times 4, which is 12. Okay, let's solve this thing for X. So the 4 and the X are secretly multiplying. So the way that I move 4 to the other side is by dividing it on both sides. Okay, which 4 divided by 4 will cancel and turn to 1. 12 divided by 4 is 3. Now don't forget, for your final step, you must include those units or I have no idea what you're talking about. 3 what? Well, our units are given to us. We're trying to find the height of the post. So all of our units are given to us in meters. So the height of the post is 3 meters. And guess what, guys? That's it.